Oh, that's me. You're probably wondering how I ended up in this situation.
Well, it all started when we decided to demonstrate how the pH of a water-based solution changes when you add a solid carbon dioxide to it. To begin, we will add warm water to a beaker, which Eliza will now model for you. We will then add about 10 drops of universal indicator. You're probably wondering, what is universal indicator? Well, it's a mix of a lot of different things that change color to show a thing called pH, which we'll get into later. When the universal indicator touches different types of materials, it will produce a certain color. This color can be matched to a color on a reference sheet, which will tell us the number of the pH. And we will add a small amount of sodium hydroxide until the solution turns purple. Sodium hydroxide is a basic substance, so the universal indicator will turn purple to show this. We use a pipette to transfer the NaOH into the beaker. Here we are comparing our new solution of sodium hydroxide, universal indicator, and warm water to our color reference sheet, and we see that the color of pH that is produced is around 11 to 12, which means it's strongly a basic solution. Now we are going to transfer our solution from the beaker to a larger graduated cylinder. We will then carefully add our piece of dry ice into the solution using thick gloves to ensure safety. We had to use a hammer to break up the dry ice into pieces. Dry ice is very cold and can give you frostbite if touched. The solution is now bubbling and releasing a lot of gas, which we can see. Changes happen very quickly and then much more slowly, so we will use a time lapse to watch the changing of the colors. We will then compare the color of our final solution, where no change has occurred in color for a significant period of time, to the color reference sheet included with our universal indicators provided, and determine the pH of the final solution. The rusty orange color produced indicates an acidic solution according to the reference sheet, as shown above. The solution is aqueous, meaning dissolved in water. Therefore, when the solid dry ice is added to the solution, the phase transition sublimation occurs. Sublimation is the act of transitioning directly from the solid phase to the gas phase.
Dry ice is the common name for solid carbon dioxide. Carbon dioxide is usually a gas, but when it gets very, very cold, it turns into a solid. Because it has to be so cold, when dry ice is exposed to the room temperature air, it turns straight from a solid into a gas, without melting into a liquid first, which is where it gets the name of dry ice. In this experiment, the color of the liquid changes because of a change in something called pH. pH stands for power of hydrogen, but it tells us how acidic or basic something is. Something acidic, like a sour lemon, would have a pH of a lower number on the pH scale, while something basic, like bitter soap, has a higher number pH. The indicator tells us the pH of the liquid we put in by changing colors. For example, as we can see on this color reference sheet, the indicator will be yellow at a pH of 6. So by looking at the yellow color, we can determine the approximate number of the pH and see if the solution is acidic or basic. In our experiment, we start with the dark purple color. Checking our key, we see that this indicates a pH of 11. This must be right because we have added basic sodium hydroxide to the water, and a pH of 11 is basic. Now, when we add the dry ice, the color starts to change, meaning the pH is changing. If we follow along with our reference sheet, we see that the pH is getting lower and lower, meaning the liquid is becoming more and more acidic. But why? The change occurs because of a chemical reaction between the water and dry ice. Water and carbon dioxide react and create a new substance called carbonic acid. However, carbonic acid is very weak, and so it falls apart into two different pieces, hydroxide and bicarbonate. Hydroxide makes the mixture turn more and more acidic, so the color changes.
Although this experiment might look like a magic witch's brew, it's actually really simple and explainable by science.